Energy transfer in the atmosphere. Energy from the sun. The sun provides most of Earth's energy. This energy drives winds and ocean currents and allows plants to grow and produce food, providing nutrition for many animals. When Earth receives energy from the sun, three different things can happen to that energy, as shown in Figure 11. Some energy is reflected back into space by clouds, particles, and the Earth's surface. Some is absorbed by the atmosphere or by land and water on Earth's surface. Heat. Heat is energy that flows from an object with a higher temperature to an object with a lower temperature. Energy from the sun reaches Earth's surface and heats it. Heat then is transferred through the atmosphere in three ways: radiation, conduction, and convection, as shown in Figure 12. Radiation. Sitting on the beach, you feel the sun's warmth on your face. How can you feel the sun's heat even though you aren't in direct contact with it? Energy from the sun reaches Earth in the form of radiant energy, or radiation. Radiation is energy that is transferred in the form of rays or waves. Earth radiates some of the energy it absorbs from the sun back toward space. Radiant energy from the sun warms your face. Conduction. If you walk barefoot on a hot beach, your feet heat up because of conduction. Conduction is the transfer of energy that occurs when molecules bump into one another. Molecules are always in motion, but molecules in warmer objects move faster than molecules in cooler objects. When objects are in contact, energy is transferred from warmer objects to cooler objects. Radiation from the sun heated the beach sand, but direct contact with the sand warmed your feet. In a similar way, Earth's surface conducts energy directly to the atmosphere. As air moves over warm land or water, molecules in air are heated by direct contact. Convection. After the atmosphere is warmed by radiation or conduction, the heat is transferred by a third process called convection. Convection is the transfer of heat by the flow of material. Convection circulates heat throughout the atmosphere. How does this happen? When air is warmed, the molecules in it move apart and the air becomes less dense. Air pressure decreases because fewer molecules are in the same space. In cold air, molecules move closer together. The air becomes more dense and air pressure increases. Cooler, denser air sinks, while warmer, less dense air rises, forming a convection current. As Figure 12 shows, radiation, conduction, and convection together distribute the sun's heat throughout the atmosphere. The water cycle. Hydrosphere is a term that describes all the waters of Earth. A constant cycling of water within the atmosphere and the hydrosphere, as shown in Figure 13, plays an important role in determining weather patterns and climate types. Energy from the sun causes water to change from a liquid to a gas by a process called evaporation. Water that evaporates from lakes, streams, and oceans enters Earth's atmosphere. If water vapor in the atmosphere cools enough, it changes back into a liquid. This process of water vapor changing to a liquid is called condensation. Clouds form when condensation occurs high in the atmosphere. Clouds are made up of tiny water droplets that collide to form larger drops. As the drops grow, they fall to Earth as precipitation. This completes the water cycle within the hydrosphere. Classification of world climates is commonly based on annual and monthly averages of temperature and precipitation that are strongly affected by the water cycle. Earth's atmosphere is unique. On Earth, radiation from the sun can be reflected into space, absorbed by the atmosphere, or absorbed by land and water. Once it is absorbed, heat can be transferred by radiation, conduction, or convection. Earth's atmosphere, shown in Figure 14, helps control how much of the sun's radiation is absorbed or lost. Why doesn't life exist on Mars or Venus? Mars is a cold, lifeless world because its atmosphere is too thin to support life or hold much of the sun's heat. Temperatures on the surface of Mars range from 35 degrees Celsius to negative 170 degrees Celsius. On the other hand, Gases in Venus's dense atmosphere trap heat coming from the sun. The temperature on the surface of Venus is 470 degrees Celsius. Living things would burn instantly if they were placed on Venus's surface. Life on Earth exists because the atmosphere holds just the right amount of the sun's energy.